Good afternoon, children. Once again, welcome to One Mark Solution. And please subscribe, like, and share to your friends. And let us move on to the assertion and reason for the magnetic effects of electric current. That is the third unit. Now, we can say the weightage also is more in this chapter. So please study the concept, children. Let us move on to the first assertion and reason. So the first one we can say, the range of a voltmeter can be both increased or decreased. That means you know that galvanometer can be converted into voltmeter and ammeter. When a resistance, high resistance is connected to a galvanometer, we can convert galvanometer into a voltmeter. If you are connecting a small resistance, that means very low resistance with parallel, we can convert galvanometer into a ammeter. And these two, I think all of you are doing for the practicals also. And what is the equation for the range of a voltmeter? That means how will you calculate the resistance to be connected to the voltmeter? The equation is given here. R is equal to V by Ig minus G, where V is the voltmeter. That means range of voltmeter. If it is 3, you can put it as 3. And Ig is the current flowing through the galvanometer. And capital letter G is the resistance of the galvanometer. If you are substituting all these values, we will get the resistance to be connected in series with the galvanometer. So that is correct. Absolutely correct. The assertion is correct. Let us move on to the reason. The required distance to be connected in series can be calculated by using the relation given. So that is also correct reason, and the assertion is correct, and that is a correct explanation for the assertion also. So the option will be A, and the conversion is very, very important. Please study it. Now let us move on to the assertion second. Both ampere meter squared, A for ampere, M for meter squared, it is square, and joule Tesla raised to minus 1. Ampere meter squared and joule Tesla raised to minus 1 are the units of magnetic dipole moment. All of you note this point. You know that ampere meter squared, that is M is equal to IA. So I is current and what is it? Area is meter squared. So we can say area into meter squared is the unit of magnetic dipole moment. All of you know that. But the new unit, how it comes means when you are dividing, that means you just split area and ammeter in terms of what is it, magnetic field and all, you will get the joule Tesla raised to minus 1. Please go through that also. So the assertion is absolutely correct. Now let us move on to the next one. Both the units are equivalent to each other. Correct. Both the units are the magnetic dipole moment, right? Units of the dipole moment. So we can say assertion and the reason are true, and the reason is absolutely correct for the assertion. So the option A. Now move on to the third one. The true geographic north direction is found by using a compass needle. True geographic north, we can't find it out. If you are putting a compass needle or if you are just placing a compass needle freely, it will be pointing towards the magnetic, poles. It is not geographic north direction, isn't it? So the reason it is given as the magnetic meridian of Earth is along the axis of the rotation of the Earth. Magnetic meridian of the Earth is not along the axis of the rotation. It is inclined to some angle. It is there very clearly in your textbook. That is the axis of rotation and the magnetic meridian. Meridian means you know that, isn't it? It is a vertical plane which passing through the magnetic axis. Magnetic axis and the axis of rotation, that is geographic axis, it is inclined to an angle. It is 11.2 degree, we can say it is magnetic declination. So here we can say both assertion and reason is false. Now let us move on to that. Option is D. Let us move on to the fourth one. We can say if a compass needle is kept at magnetic north pole, we are placing in the north pole needle. The compass needle may stay in any direction. That is absolutely correct. It won't go to the any direction. Why? Because it already placed in the north pole. So assertion is correct. What about reason? The dip needle. I think you know that dip is measured using dip circle. So the dip needle will stay vertical at the north pole of the Earth. Yes. Why? Because at the poles we can say, what is it? The magnetic field will be vertical. So here we can say it is not the reason for the first one. Reason is correct, assertion is correct. But reason is not the absolute explanation for the assertion. So the option B. Then these we can say magnetic declination, magnetic inclination, and horizontal components are the magnetic elements of the earth that you have to study. It is very clearly, it is mentioned in the textbook. Please go through it. Now we can go for the next one. You can see a figure here. The magnetic field at the center of the current carrying circular coil, one circular coil is here. And you can see, what is it? A direction is also given. It is going in this direction. So we will cut into two halves, semicircles. The first semicircle we can say it is clockwise. You can see it is clockwise. So what is the direction of the magnetic field? Using right hand thumb rule we can say. Using right hand thumb rule, this is the magnetic field and this is the curlings of the finger. That is the current and this is the curlings of the magnetic field. Reverse we can say. If this is the direction of the current, this will give the direction of the magnetic field. So always keep in mind, the thumb gives the north pole. So if I'm just keeping in this manner, that is anti-clockwise, the north pole we can see. If you are keeping in the opposite direction, north pole is in the opposite direction. Here it will be south pole. So here we can say the direction, the first half we can say direction is south pole and the second half that is in the anti-clockwise, it will be the north pole. So they cancel each other. Why they are cancelling each other? Why? Because the same current is flowing through it. I is not changing. So what is the equation for the magnetic field at the center? We can say mu 0 by 2 I by A. So I is constant, radius is constant, and we can say magnetic field is also constant. Magnitude is constant. Direction is opposite, so they cancel each other. So the answer will be 0 here. What is the reason? We will see that. The magnitudes of the magnetic field are equal and the direction of the magnetic field is due to both the semicircles are opposite. That is absolutely correct. So both assertion and reason are correct. And reason is the correct explanation for the assertion. So the option A we can say. Now let us move on to the sixth one. See here, the voltage sensitivity may not may not necessarily increase on increasing the current sensitivity. Why? Why? Because we can say in the case of voltage sensitivity, we are adding R also. That means voltage sensitivity, we can say Vs is equal to phi by V. What is V? I into R. So additionally, R is also there. Phi by I is current sensitivity. So additional one R is also there. That is why we can say may not necessarily increase on the increasing current sensitivity. Voltage sensitivity depends on R also. We'll go for the reason. Current sensitivity increases on increasing the number of turns of the coil. Yes, of course, we can say that. Why? Because the equation for Is is equal to phi by I. So the equation becomes, we can say that NBA divided by C. N is the number of turns, B is the magnetic field, and A is the area. So it depends on the number of turns. When number of turns increases, current sensitivity also increases. And this topic is also very important, children. Please note this. Sensitivity, two sensitivities are very important. So the answer, we can say B, the option is B. Why? Because assertion and reason is absolutely correct, no doubt. But in the case of the first one, we are telling about the voltage sensitivity. And the second case, we are dealing about the current sensitivity. So we have to explain the voltage sensitivity here. So the option is B. It is why? Because reason is not the correct explanation for the assertion. That is why. Now let us move on to the seventh one, children. Angle of dip is maximum at the poles of the earth. How you will get it? We know that the magnetic field, the earth's magnetic field is inclined like this. It is divided into two. One is vertical component, the other one is horizontal component. At the case of the pole, we can say only vertical component is there. That is BV is equal to B sine delta. Delta stands for the angle of dip. That is angle of inclination. So B sine delta is equal to B. That means maximum. So what is sine delta? 1. If sine delta is equal to 1, what is delta? Delta will be 90 degree. So angle of dip is maximum, that is 90 degree at the poles of the earth. We will go for the reason. The magnetic field lines are parallel to the surface of the earth at the poles. No. Magnetic field lines are poles, we can say vertical. So what is the answer here? A is correct and the reason is false. The option is C. Now let us move on to the eighth one. An electron projected parallel to the direction of the magnetic force will experience maximum force. Electron is projecting parallel to the direction of the magnetic force, we can say. So we'll experience maximum force. What is the equation for the force? We can say F is equal to QVB sine theta. Here we can say it won't experience the maximum force if it is parallel. Theta is 90 degree, then only it will experience maximum force. Reason we can read it. Magnetic force on the charged particle is given by F is equal to IL cross B. No. The equation is QVB sine theta, or we can write Q into V cross B. So both assertion and reason is false. Let us move on to the next. Before that, you can see that the correct option is D. Now move on to the next one. The torque acting on a square and the circular current carrying coils having equal areas placed in uniform magnetic field will be same. What is the expression for the torque? Torque we can say NIAB sine theta. So here we can say I is constant, area is constant, so torque also will be constant. So that is why area is equal areas is specifically they are saying. So torque will be maximum. Then what is the reason behind? Torque acting on a current carrying coil placed in a uniform magnetic field does not depend on the shape of the coil if the area of the coils are same. Correct. That means it depends on the area, does not depend on the coil. And you have to note this point also, can be asked for the board exam. So the what is the answer here? We can say A. Reason is the correct explanation for the assertion and both are true also. So the option is A. Once again, we can go for the next one. A phosphor bronze strip is used in a moving coil calorimeter. Why phosphor bronze strip is used in a moving coil calorimeter? Why? Because to get more sensitivity, we are using this. And what are the specialty of this phosphor bronze strip? It is the best conductor, we can say. Tensile strength is high. Why? Because they have to carry the whole coil. So tensile strength should be high. And low torsional constant. Then only we will get more deflection. If you are getting more deflection, then only we can say sensitivity will be more. So the equation for the sensitivity, we can say that, what is it? Phi is equal to NBA divided by C. So if C is very low, then only the deflection will be more for a steady current, we can say. So we will go for the reason a phosphor bronze strip has a maximum value of torsional constant. No, it should have the low value of torsional constant. So assertion is true and the reason is false. So that is the option C. Thank you, children. Thank you for watching. Thank you.